algebra is one of the most important subjects in mathematics. It permeates mathematics and all the mathematical sciences, and it's really impossible to get past a certain level of understanding without pretty solid algebra. To make an analogy, it's similar to grammar in a language. You may be able to get something of the idea behind what's written, but you'll never fully understand it, let alone be able to reproduce it yourself. So algebra is absolutely vital to everything you're going to do at university in mathematics. So what I want to do is to really look at algebra from a university type perspective, but go through the fundamentals. So kind of explain the most basic properties of algebra that you're going to need. And when I'm talking about algebra here, really I'm going to be thinking about algebraic operations. And when I say algebraic operations, what I really mean is are four basic ways of combining numbers. So algebraic operations, I'm going to be talking about addition, subtraction, multiplication, and division. So that's what algebraic operations are. Okay, so really what we want to understand is the properties of these. So what do I mean by properties? Well, properties are things that are true for all numbers, essentially. And really, a nice way of thinking about algebra itself is the following. Algebra is the study, if you want, of the general, so I'll talk about what that means in a second, the general properties of these four operations: plus, take away, multiply, and divide. Okay, it's the study of the general properties. So before we start talking about what general properties are and giving some general properties, I think it's important to recall some of the subtleties to do with how we perform these operations. So unfortunately, if I take a string of numbers and I take a string of operations, addition, subtraction, division, it really matters what order I do them in. And this can cause a lot of confusion. So there is a standard convention about the order that these operations have to be carried out in. So let me just allude to this a little bit. This is not a huge issue, but it's something that I think is worth pointing out. So the order of operations. So when we write expressions, so a string of numbers with operations between them, something we very commonly do is write parentheses around them to indicate that certain parts are clumped together and should be calculated first. So the order of operations is parentheses first. Those should be looked to begin with. Parentheses. Next, you look for exponents. So things like 2 to the power 3, 4 to the power 6, that kind of business. Next, so this is a little bit more subtle. The next, you basically worry about multiplication and division, and you do it simultaneously. So the next thing I'll write is multiplication or division. So it could be either, and I'll explain why in a second. And then the next, well, subtraction or addition and subtraction. Or subtraction. Addition or subtraction. Okay, so this multiplication or division or addition or subtraction business, well, first of all, the reason we're clumping together multiplication and division is because actually they're the same thing, just from a slightly different perspective, and the same thing with addition and subtraction, something we're going to talk about in a little bit. But when we're doing these multiplication or divisions or additions or subtractions, we should be looking at my expression and reading it from left to right. And whatever I hit, a division or a multiplication, for example, I do that. So I'll give an example in a sec, but I just want to write this down. So these guys, we can read these read from left to right if you want. Okay, so let's do an example. So here's one that's easy to kind of get lost in or maybe make a mistake with if you can't remember this basic convention. So let's do 3 plus 16 divided by 4 times 3. Okay, so let's think about this carefully. The first thing we need to do is to kind of go through the options. In fact, maybe I'll change this a little bit. Let me put a 2 to the power 2 here, just to really illustrate the point. So what do? Are there any parentheses? No, no parentheses. Any exponents? Yes, right? There's a 2 to the 2. So let's write that as just an ordinary whole number. Okay, then what? Well, next it's multiplication or division. And I can see both happening. There's a division and there's a multiplication. But remember what the rule is. You read it from left to right and you do whichever one comes first. So the first is the division. So it would be 16 divided by 4, which is 4. So this is 3 plus 4 times 3. Then you repeat this process. Well, there's a multiplication. And that beats the subtraction if you want, or it comes first. Or the addition, sorry. So that would give me 3 plus... Let me just move this down for a bit more space. This would give me 3 plus 12, and that would give me 15. Very nice. So the basic deal is you go through each of these carefully, one at a time, and you are careful. When you're doing this multiplication or division, addition or subtraction, you read it from left to right. Something I will say is I'm a big fan of using parentheses to cut out the confusion in this type of problem. So I think it's much safer to include a few parentheses rather than rely on the fact everyone can remember this order. So I think it's safer, or maybe I should say slightly too many even. Slightly too many is safe. It's better to include a few too many parentheses to really indicate what's bunched together. So what I mean by that here would be, I think it'd be much more sensible to write this as 3 plus, well, let's bracket the 16 and the 4 multiplied by 3, and then let's really indicate that these are together with a big square bracket. See, it's exactly the same thing, but this really clearly indicates, or maybe I should do 2 to the 2 to be, that really clearly indicates how things are bunched together. So what you will find overwhelmingly is that at university, we don't rely on remembering this fairly arbitrary rule. We use brackets and parentheses a lot, so that, and when I say brackets and parentheses, they're exactly the same, right? They're interchangeable. We use parentheses a lot just to really indicate what's going on. So this isn't going to be an important part of your university mathematical experience at all, but it's something to point out, I think, right? Especially for the use of parentheses, which is going to be very important. So next what I want to do is talk about the concept of a general property. So this is something which causes a lot of confusion when you first learn about algebra, largely because the way we express general properties is using letters and not numbers. And every one of us, when we first started doing algebra at school, middle school, whenever it was, when we saw x's and y's, it was like some sort of mystical thing. It's like, what does this mean? Really what it means is it's a stand-in for a number. And whatever you're writing down is something which is true of any numbers, so there's no point in writing down every single possibility. We just use a letter to represent it, right? It's quite an abstract idea. But let me be really concrete about this. Let me give you a difference between a specific property and a general property. So let's do specific versus general. Specific versus general. So let me make a very specific statement about addition, for example. An extremely specific statement would be 3 plus 5 is equal to 5 plus 3. Okay? Very simple. Right, the definition of addition involves kind of an order. You look at 3 first and 5, or 5 first and 3. And one of our basic rules is that, or a fact is that it doesn't matter which way around I do this, I always get 8. Now, this is true of 5 and 3, of course, but we also know it's true of any other numbers we choose. So a general property would be the statement that the sum of two numbers is the same regardless of the order you do it in. So you could say that out loud. It would be quite hard to always have to write things in long kind of sentences. So instead we say, well, let's represent a number with a symbol. What symbols do we have other than numbers? Well, we'll choose some letters. So a general statement here would be this. And what we're doing here is making a statement about all numbers simultaneously, and we're doing it symbolically by representing all numbers with just these symbols which happen to be letters. So this is true for any number. Any numbers A and B. Something I will say about numbers. Numbers, there's lots of different types of numbers really. They're all very closely related. There's whole numbers, right? Things like 1, 2, 3, 4, 5, 0, -1, -2. We also call those the integers. Then there's rational numbers, which are fractions, real numbers, which are decimals, and some of you may have heard of complex numbers, which are a little bit more complicated. Throughout everything we're going to do here, everything is going to be real numbers. Everything I'm going to say, I should add, is true of all numbers, especially complex numbers. But overwhelmingly, we're going to look at real numbers. That's going to be the focus. So real numbers, it is decimals. So the first thing I want to do is to look at the absolute simplest properties of my two, what I would say core operations are. So my core operations are addition and multiplication. We're going to see in a moment that subtraction and division are actually just addition and multiplication in disguise. So let's look at the fundamental properties of addition and multiplication. So these are the most basic universal properties that they satisfy. So fundamental properties of, let's say, addition and multiplication. So what I'm going to write down, it's going to be a bit funny looking, I think. I mean, you're probably quite used to doing quite difficult algebra, and this is going to be incredibly basic. But what I really want to stress is, to really be good at algebra, you have to truly, really understand the basics, the fundamentals. It's one of these things that the better you understand the foundations, overall, the stronger your algebra will be. So that's why I'm going to really take my time to look at the absolute most basic properties. So first of all, let's choose three numbers represented just by three letters. So these could be any numbers at all. So for all numbers, so let's write A, B, and C. The following is true. So let's do addition first. I think that's the simpler of my two operations. Okay. There are four properties of addition which are completely ubiquitous everywhere. The first is, well, I said a moment ago, when we add things, we kind of, as a rule, add two things at a time. So if I give you three things to add, it's like, well, how do you do it, right? How do you bunch things up? So if I give you A, B, and C, and I add them, well, I've got two obvious choices. I've got this, or I've got this. And it is a fact they are equal to each other. Okay, so feels totally obvious, but only because you've used it so often. So this means if you take three numbers A, B, and C, you could just write A plus B plus C without writing a parentheses, because there's no point, right? Because you know you get the same thing at the end. So that's a very simple property. Next property. 0 is very nice when it comes to addition. If I add 0 to anything, it leaves it the same. It's kind of the defining property of 0, really. Next, there are negative numbers. And that means if I take a number A, I can always find the negative of it, whatever it might be. And if I add it to it, so done the same thing again. If I add it to it, I get 0. Super basic property, very important. It's the defining property of what a negative number is. Finally, and I've already alluded to this a second ago, a plus b is equal to b plus a. The order does not matter. So these are the absolute foundational properties of addition. Right? They are the most important core properties of addition. Let's do multiplication. First property. It's basically exactly the same as the property we've just seen for addition. If I multiply 3 numbers, it doesn't matter how I bracket them. And these two properties are so similar, they're given a name. This idea of the bracket not mattering, this is called the associative property. The name doesn't really matter. It's not going to turn up a huge amount, certainly not in lower division mathematics classes, but it's kind of nice to know that they share this property. The next. Well, 0 has this very prominent role when it comes to addition, because if I add it to anything, it stays the same. There is a number which has exactly the same property with respect to multiplication, namely 1. So if I take any number and I multiply it by 1, on either side, it doesn't matter, it's always the same, leaves it fixed. That basically is the defining property of 1. Next, well, are there negatives? What would the equivalent of a negative be? So I suppose the equivalent of a negative would be something that I would multiply with a number which would give me 1. That would be kind of the equivalent on the multiplication side. So that's going to basically be the statement that there are inverses, isn't it, right? Things have inverses, like 2 has an inverse, namely a half. I do need to be careful, though. I do know that 0 can't have an inverse, right? I can't multiply anything by 0 to get 1, because 0 times anything is always 0. So I can't really divide through by 0 if you want. So what does this mean? Well, if we've got to be a little bit careful, if a is not equal to 0, I have an inverse, and I'll write in fractional notation. And if I multiply it by my number, I always get 1. Very nice. So something like 2 times a half is equal to 1. And that works for any number as long as it's non-zero. Finally, we have exactly the same kind of story as with addition. We've got this property where it doesn't matter what the order is. Very important. And these two last ones are so similar, we're going to give them a name in common as well. So I'm going to call this the commutative property. So commutative is one of these words that you use when you talk about the order not mattering. You can switch it. Not everything you're going to encounter in lower division mathematics and beyond is commutative, as we're going to see. And even in this course, we'll see things which aren't commutative, but addition and multiplication are. So these are the 4 foundational or fundamental properties of addition and multiplication. There is one more thing, though. And if you notice, on both sides, I'm kind of talking about these as if they're completely isolated from each other. The addition stuff, there's no mention of multiplication. The multiplication stuff, there's no mention of addition. There is a relationship between the two, which really is what makes arithmetic so complicated when it comes down to it. It's the following property. So let me indicate the fact this involves both addition and multiplication as follows. So this property is the following. If I multiply a number by a sum, and the sum is done first, as indicated by the parentheses, then this, if you want, multiplies out to be a times b plus a times c. Okay, and let's just really hammer this home with this. So this property is basically the fundamental interaction between addition and multiplication. And it's given a name. It's called the distributive property. And this one we are going to use an awful lot. In my opinion, the key to getting very solid algebra is having a really good feeling for the distributive property. So many pieces of algebra that you may have messed up before, it will come down to a failure to apply the distributive law property or distributive property correctly. So this is it. This really is the fundamental properties of addition and multiplication. It may seem crazy, but even the most weird, difficult piece of algebra you've done will always boil down to these properties, right? They're kind of like the atomic pieces of information about addition and multiplication. Now, I said before that addition and multiplication, I'm doing them only these two because actually subtraction and division are these in disguise. So let's just take a moment to do some notation, really. So when we write A subtract B, A take away B, what that actually means really is A plus minus B. So subtraction really is just addition in disguise. Similarly, when we write A divided by B, what we really mean there is A multiplied by the inverse of B. And of course, for this to make sense, we have to have B non-zero. So both of these are essentially the meaning of subtraction and division, right? That's what they mean. So these are, if you want, the definition, so the actual meaning of the two of them. The definition of subtraction and division. There's nowhere back from this, essentially. This is what they mean, right? This is the defining property of them. So this latter one, it's worth writing this slightly different notation. It's very cumbersome to write this. Much more standard notation, we write A over B. So this is fractional notation. And it's important to know a few of the names of different pieces. So the top is called the numerator. And the bottom, of course, is called the denominator. Okay, so subtraction is just addition of the negative. Division is just multiplication by the inverse. So let's just recap. We have these four fundamental operations of arithmetic. We have addition, subtraction, multiplication, and division. And they satisfy a key collection of completely foundational properties that we're going to see give rise to all of the properties of algebra that you're used to doing. The manipulations you're used to doing in more complicated settings will all essentially come back to these specific examples when it comes down to it. So next time we'll look at the consequences of these foundational properties, and really I'm going to summarize the absolute core kind of algebraic manipulations that you need to internalize to do any algebra at all.